is Algebra 2, Lesson 59. It's on page 252 in your book. And we're going to be talking about experimental data, simultaneous equations with fractions and decimals, and going from the rectangular form to the polar form. So, let's start with experimental data. Linear graphs and two equations do have many applications in real life, I promise. In chemistry, among other sciences, the relationship between variables can often be expressed using linear equations, and thus their graphs are straight lines. Laboratory experiments are used to confirm theories. If theory indicates the relationship is linear, we estimate the line based on the data points, and then we write the equation of the line using the variables in the place of x and y. The data graphed on page 252, I'm going to pull this over here so you can look at it instead of trying to redraw it. So this data right here came from an experiment involving bronze and copper. The shadows around the points indicate that due to potential errors, the data may not be exact. So the question is, write the equation of the line which gives bronze as a function of copper, and note the difference in scales. Here we're going up by tens, here we're going up by fives. Okay, if bronze is a function of copper, then copper is the independent variable, and we use it in place of x, and it's graphed horizontally. And bronze is the dependent variable, and it's graphed vertically. Okay, I'm going to move the book. So bronze is our y, and copper will be our x. So the formula for a linear graph involving bronze and copper is going to be bronze equals the slope times copper plus the y-intercept. Okay, looking back at the graph, we're going to find a place on the line where a data point comes very close to the line. So looking back at the graph, they chose this spot right here where this data point comes very close to 15 kilograms of copper and 40 kilograms of bronze. So that's the point we're going to use to find the slope. So now we have b equals, you remember slope equals y over x. So the y was 35 because they started at the 5 in the y. And the x will be 10, okay, which equals 3.5 copper plus b. Okay, now we're going to use the coordinates of one point on the line to solve for b. They used 15 and 40 because that spot comes really close to the line again. So we can put the 40 in for the bronze equals 3.5 times 15 plus b, and now we're going to solve for b, which of course is the y-intercept. So 40 minus 52.5, so b equals negative 12.5. Okay, so our equation will be bronze equals 3.5 copper minus 12.5, and this is actually measured in kilograms. Let's look at the second example. We'll bring back the next graph. Okay, this graph is on page 253, and this graph is nitrogen as a function of sulfur. It's in grams, and once again the scales are very different. Okay, if nitrogen is a function of sulfur, then our formula is going to be nitrogen equals slope times sulfur plus the y-intercept. You can look at page 253 and see which point they chose. The point they chose is at 6.4 over 35, which equals 1.18. So nitrogen equals 0.18 sulfur plus the y-intercept. They're choosing the point 10 and 1. So we have 10. Oops, sorry. We have 1 equals 0.18 times 10 plus b. And now we're going to solve for b. So 1 equals 1.8 plus b. Subtract 1.8 from both sides. And b equals 0.8 grams. Negative 0.8 grams. Okay, so we have N equals 0.18 sulfur plus, minus 0.8 grams. Right, let's go on to another one. The next section is on doing simultaneous equations with fractions and decimals. Okay, here are the problems we're going to start with. When we have simultaneous equations with fractions and decimals, our first step is to change the equations so that all the numbers are integers. Okay, so for x over 2 plus 3y over 5, which equals minus 2/5. So for this problem, we're going to start by finding the lowest common multiple and multiplying it through so that the bottoms cancel and we're only left with a numerator. So in this case, the lowest common multiple is 10. So let's multiply 10 times all of the terms. So we have 5x plus, this will be a 2, so 6y equals, this is also a 2, negative 4. For this one, we're going to multiply times 100 to take care of all the decimals. So they call this A prime. This is going to be B prime. We're going to multiply times 100 and times 100 to move the decimal over 2 places. So this will be 6x minus 20y equals 104. Okay, these problems are actually the same. A and A prime have the same value, and B prime have the same value because we can factor back to the original problem. So the values are the same. Okay, now we can solve these equations by using the elimination method. So we can do fx plus 6y equals negative 4 over 6x minus 20y equals 104. We need to find a common multiple for the coefficients. For either x or y, and x is going to be easier, so the common multiple of these would be 30. So we're going to multiply the top times 6 and the bottom by 5. So this will be 30x plus 36y equals negative 24. And we're going to multiply the bottom one times 5. So this is 30x minus 100 equals 520. And we actually, because we want to divide, we're going to multiply this one through by negative 1. That changed this to a negative and this to a positive. Now we can add. So the x's cancel out. This becomes 136y equals 544. And when we divide this through, y equals negative 4. Now we can substitute that back into one of the problems. I'm just going to use this one because it's easier. So 5x plus 6 times negative 4 equals negative 4. 5x plus minus 24 equals negative 4. Add 24 to both sides. 5x equals 20. So x equals 4. So your answers would be y equals negative 4 and x equals 4. And if we wanted an order paired, then it would be 4 and negative 4. Okay, next we're going to talk about how to go from rectangular form to polar form. You remember the rectangular form looks like this. Negative 5r, that means it's going to the left, minus 3u, which means it's going down. So it'll be in quadrant 3. And we're going to go from this to polar form, where h is the magnitude or the distance from the origin, and the theta is the degrees from the x-axis. Okay? So we can convert a number from rectangular form to polar form by using the rectangular coordinates to find the tangent of the line, and then we'll find the inverse tangent to find the angle. Now the book says to find inverse tangent on your calculator you find an inverse button and then the tan button. On my calculator, above the tan button in little lines it says tan negative 1, which means the inverse of the tangent. So I hit the function button and then the tangent button, and that finds the inverse. So you just need to look on your calculators and see if it's an inverse button or if it's just function tan. Okay? Okay, so here's the example. We're going to convert negative 5r minus 3u to polar form. So I would draw it, but they do a much better job drawing than I do. So here's where this angle is. The end of our line is at negative 5 and negative 3. Here's the h, which is the magnitude. This is the right angle. This is the hypotenuse. Here's the angle we're starting from. So tan equals, the tangent equals the opposite over the adjacent. So we're going to be using this distance and this distance. Okay? So the tangent of the angle is the opposite over the adjacent. In this case, that equals negative 3 and negative 5. Those cancel, of course. So the tangent of the angle is 3/5. And if you take the inverse of the tangent of 3/5, you're going to find the angle. In this case, the angle is 31 degrees. Okay, so this is our angle. We have this part now. Now we need to find the h. Now remember, the h is the hypotenuse. So if the angle goes like this at 31 degrees, and here's the right triangle, this is h, this is negative 3, this is negative 5. So we can find h a couple of different ways. We can take the sine of the sine of negative, the sine of 31, which would be negative 3 over h, or we could find the cosine of 31, which would be negative 5 over h. So we'll just do the sine. So the sine of 31 degrees equals 3 over h. So the sine of 31 is 3 over h, and therefore h equals 3 over the sine of 31 degrees. And when you work that out on your calculator, h is going to equal 5.83. Okay, so now we know in polar form that our h is 5.83. Now we need to be careful with the theta, because we've been using this 31 degree angle, but remember this angle is actually in quadrant 3, right? So this is actually 180 degrees plus the 31. So the angle that this 5.83 is at is actually 211 degrees, because that's 180 plus 31. Okay, an alternate way of finding this angle, or the polar coordinates, would have been to start back here again and to use the Pythagorean theorem instead of finding the sine or cosine. So if we do that, we have, remember, it's 3 squared plus 5 squared equals h squared. So then if we take the square root of both sides, we have the square root of 9 plus 25, which equals the square root of 34. So we could also have said the square root of 34 to the angle of 211 degrees. And of course it turns out that the square root of 34 is approximately 5.83. Okay, that's it. Thank you very much. Let me know if you have any questions.